What's above and below our solar system? Today, if you were to be thrown far enough beyond the solar system, you'd be able to see it in its entirety. The flat universe you think you know? It's far more complex than you imagine. We often picture the solar system as a giant, flat disk, with the 8 planets speeding around the sun, almost on the same plane, like cars racing on a track. This isn't a coincidence. It stems from the primordial gas and dust cloud that formed everything billions of years ago. But have you ever stopped to think, if our solar system is flat, then what's above and below it? At first glance, this seems like a simple question, but the concept of up and down is deeply rooted in our experience with gravity on Earth. In the vast expanse of the universe, there is no cosmic compass pointing to a specific up. All directions are relative. This so-called plane of planetary orbits roughly aligns with the Sun's equator, but it's not perfectly aligned. Mercury tilts about 7 degrees, and the once 9th planet, Pluto, tilted by nearly 17 degrees. As for comets, they don't seem to care about this plane at all. Many comets from the far reaches of the solar system pass through at extreme angles, cutting through the solar system like a needle through a vinyl record. So, does up and down even exist in the universe? On Earth, up is the sky, down is the ground, defined by gravity. It's simple and clear. But once you venture into space, this logic breaks down. It's like floating in the middle of an ocean, far from land, with no landmarks to reference. Every direction feels the same. There's no fixed ground, no universal north. An astronaut relative to another might be upside down, but neither is wrong. It all depends on your perspective. One galaxy might look right side up to one observer and tilted to another. So, when we talk about the up and down of the solar system, we're using the planetary orbital plane as an arbitrary reference. This plane is called the ecliptic plane. It is more like an imaginary grid we use to navigate the universe. It has no physical meaning. It's a tool we created to help us explore space. Following this line of thought, what do we find when we explore above and below this plane? The answer might just blow your mind. Layer 1. The invisible bubble of the Oort cloud. You might have never seen it, but it's there. Beyond the plane of planetary orbits lies the vast, spherical Oort cloud. This isn't a flat disk. It's a huge, bubble-like shell surrounding the entire solar system. Scientists believe it stretches all the way to the nearest star system, Alpha Centauri, about a quarter of the way to the star. This cloud is made up of trillions of icy bodies that were flung outward by the giant planets during the solar system's formation. Many long-period comets, with their strange orbits, are indirect evidence of the Oort cloud's existence. Imagine living in the center of a massive, invisible bubble made of icy crystals. Layer 2. The Sun's cosmic windshield, the heliosphere. Looking further out, in all directions, we encounter the heliosphere, an enormous bubble created by the solar wind, the charged particles continually ejected by the Sun. You can think of it as a cosmic windbreaker, custom-made for the solar system, shielding us from harmful cosmic radiation and cold gases from interstellar space. Since our solar system is moving rapidly through the galaxy, this windbreaker isn't symmetrical. The side facing the interstellar wind is slightly compressed, while the opposite side forms a long tail, like the trailing edge of a coat. Layer 3. The interstellar void. Beyond the outer boundary of the heliosphere, what we call the heliopause, we enter true interstellar space. But even here, it's not empty. The solar system is hurtling through a region of space known as the local interstellar cloud, a slightly dense area filled with gas and dust. Interestingly, we are currently passing through a local cosmic bubble, about 300 light-years across. This region is remarkably empty, like a vast cosmic void. Astronomers believe it may have been blown out by a series of supernovae millions of years ago. It's as if we're living in a giant interstellar room, surrounded by cosmic dust walls. So, the solar system is far from just a flat family portrait of planets. When we're used to the neat, flat diagrams of planets from textbooks, we often overlook the truth. The solar system is a dynamic, three-dimensional, complex structure deeply interconnected with the vast universe. Surrounding the planetary plane are distant, frozen worlds, rolling interstellar clouds, solar wind shields, and cosmic scars left by ancient supernovae. We're not just orbiting the sun. We're part of a grand cosmic ballet spinning, drifting, and moving through a universe shaped eons ago. Exploring the structure above and below the solar system isn't just about satisfying curiosity. It helps scientists trace the solar system's true path through the Milky Way, uncover the history of galactic evolution, supernovae explosions, and even the distribution of dark matter. After all, even our own galaxy isn't a perfect flat disk. The plane of the Milky Way is tilted by about 60 degrees compared to the solar system's orbital plane. It has bulges, spiral arms, and even curving edges. And our solar system happens to sit in a special region of the Milky Way, known as the habitable zone, where the stellar density isn't too high, avoiding excessive radiation and gravitational disturbances, yet providing the necessary elements for planets and life to form. Now, reflecting on the up and down of the solar system, what truly shocks you? Is it the invisible, shell-like Oort cloud that surrounds everything, or the vast cosmic void we're currently drifting through, created by ancient supernovae? This lack of fixed direction might be disorienting, but it's also an incredible revelation. It shows us that our usual sense of direction is just an illusion, a byproduct of living under Earth's gravity. In the layers upon layers of the vast, boundless universe, life has quietly blossomed on a tiny blue planet. Our place in the universe may be both random and ordinary because the universe, on a large scale, is uniform and isotropic, with no true center or edge. Yet, it is also incredibly extraordinary and unique. This tiny blue dot is where we, the most miraculous life forms we know of, reside. Isn't that the greatest miracle of all?